Hey guys, welcome to Packet 7. Okay, so make sure you put your name somewhere on here, date and the period, and this should be either period 1 or 6. Okay, so if you're gone for testing, we took notes here on the front, so take a moment to kind of copy the notes. I'm not going to talk through them, but you're happy to ask me questions about them. We did take notes here on page 18, page 19. So again, feel free to kind of look through these notes, ask me questions if you have any. 20, we also, we went from functions to sequences, right? Then we skipped this and this, okay? So we left ourselves a couple pages to do for our video, so let's go for it. Excuse me. So the first question here says, Kim is driving from Miami to Key West. The graph shows her distance from Key West. Okay, so here she's in Key West, right? Here she's 4 hours away from Key West. So we want to make sure what it is we are looking at, right? So distance from, oh, wait. Hold on a minute. Here, this dot, she's in Key West. Take that away. So the distance from Key West is 0. Here, she was 160 miles away from Key West. So it looks like it took her 4 hours to get to Key West, if I look at here. During what interval is Kim driving the fastest? So that would be the greatest slope or the steepest, because that's its rate of change. So that's one slope. Here's another. Here it's going at a constant speed, and then this last one. Okay, so which one is the steepest? Again, you think about a skateboarder, which one would be the scariest incline? It looks like this one is the scariest. So what interval was that? It was from 0.5 time in the x to 2 in the x. Make sense? Interesting, right? So now question number 3 says, Ronald wants to rent a jet ski. He can only ski for 5 hours, and the cost of the rental is $10 an hour. Okay, so if he can only ski for 5 hours, and the cost is $10 per 1 hour, then it looks like if he wants to ski the whole time, it would cost $50. He is required to buy a one-time insurance policy on the ski for $15. So if he wants to ski for the full 5 hours and he's got to do the insurance, that's a total of $65. What is the rate of change of his situation? Okay, so the 15 is not changing, but it looks like it's changing by $10 each hour. So the rate is $10 per hour. That is the rate. What is the context? It's dollars and hours, okay? What is the domain? So what can my x values be? Well, that's how many hours, right? So x is hours. And we can't rent it for negative hours, so hours would have to be between. And it looks like at most he can rent it for no more than 5 hours. So that is our domain, the number that describes the possible x values. All right, what is the y-intercept? So the y-intercept is always when we plug in 0 for x, what do we get for y? So here at time 0, we could either, we would say even if he is 0 hours, he still is buying this $15 insurance policy. So the intercept is 15. And what does it mean in the context? He pays $15 for the insurance at time 0 spent on the bike. All right. Last part of the question, write a function. Okay, so I think we already did that, right? It's $10. So even if I plug in 0 here, right, it's $10 per hour plus the extra 15. We call this f of x. That is our function. So again, this is our rate, and this is our y-intercept. That is our fixed cost we pay even if we don't get on the jet ski. Okay. Question number 2. Okay, Joan's family walks along a trail, goes uphill, follows the same path. Here's the graph. This depicts the elevation. So this is how high they are off the ground, and that's distance traveled on the trail. All right, identify the intercepts. All right, so that's when this is 0. So he starts the trail at, I don't know what that is, somewhere around between 100 and 200, so 150 meter elevation, right? That's how high they are when they start the trail. So they must have to drive up the mountain just to get to the height of the trail. Identify and interpret the intervals, right? What intervals? So we understand that it's increasing. So he's climbing up from the x values of 0 to, it looks like 5. And then he's climbing down the mountain, down the trail, on the interval 5 to 10. How far were they on the trail when they reached the max? So it looks like they were 5 miles into the trail, because we see here, this would be the maximum. This is what we've been working on in class, is identifying maximums and minimums. Okay, question number 4. Brad loves to surf. The table shows Brad's distance from the shore at different times. Okay, so I think this is the shore, and this is the water, and this is the beach, okay? He loves to surf. At time 0, he hasn't left the shoreline, right? At time 3, he's 20 yards offshore. So it looks like at different times, he's at different places offshore. This is when he's furthest away from the shore. It says, what is Brad's maximum distance from the shore? Okay, so it looks like that number is 40. And what is the distance from the shore? What is his minimum distance from the shore? That would be 0, where he's on the shore. This is 40 away from the shore. So what would B be? It says interpret the X-intercepts. So X-intercept is where we have an X value and Y is 0. So that's what an X-intercept is. So let's identify that. Y is 0 and Y is 0. All right, what is Brad doing at each of these points? So at the first point, 0, 0, he's on the shore and he's just starting, right? He hasn't left the shore. In the last one, he's back to shore. So at 20, 0, he's back to shore after surfing 20 minutes. Nice. How can you identify the X-intercepts without graphing the data? I can see the coordinates at some number times 0. So I'm looking where Y is 0. All right, well done, guys. All right, so that's one learning goal. There's one more learning goal we want to look at. And I don't think we have to do all 4 of these, but let's just kind of take a look at a couple of them. I really like this question. It says, a doctor wants to compare the relationship between height and shoe size. So here would be in middle school, right? And this is when you're in high school. So most of my students are between 14 and 19, right? And I did teach middle school for a couple years, and that was the age ranges when I taught there, right? So it wants us to identify the domain and describe its meaning in context. So it looks like here in middle school, the height was anywhere from, it looks like 112 to about, what is that, 138 inches. And then in high school, the height was anywhere from 150, 153 there, it looks like, to 185. So what does this mean in context? It means high school patients are taller, right, than middle school patients that come in to the doctor's office, right? And that makes sense. All right, it says the math club decided, I think I actually got to a couple of questions like this in class. So the math club decided to have a car wash and raise money for the competition. So we notice here in the beginning, they aren't making money. And this is true in any business. So you're not really making money in the very beginning because you had to pay for, soap, water, sponges, but eventually you start making money, right? So here our earnings are negative, and then the earnings become positive, right? So it says, describe the domain in the graph. So it looks like our X values are ranging from 0 to 12 cars. So we can't wash negative cars. And it looks like at the most, the math club can wash up to 12 cars. Describe the domain. The club washed a total of 12 cars. All right, let's look at one. The points on the graph show the population data in millions of the state of Florida for each decade. All right, so we see X as the exponent. That's why it's climbing like this. Should come as no surprise. What is the domain? That is our range of X values. So we notice that X is ranging from 0 to about 10, which is the decades since 1900. So 10 decades from 1900 is another 100 years, so that's a total of 2,000. So it looks like it ranges from 1900 to 2000 based on our graph. All right, we do have time, I guess. Let's just do the last one and call it a night. The income from the ticket sales is modeled. So we notice it's a frown. That's why this is upside down. And P is the price of the ticket. All right, so if we put in P, this will tell us the income. Describe the domain of the function precisely as possible. So P is the ticket price. It looks like it's ranging from 0 to 80. So P is acting on my x-axis. It's going from 0 to 80. So what does this mean? It's like the price for the ticket ranges from $0 to $80. There we have it, guys. Thanks for joining us. See you next time.